We are here to help.
The determinant of a matrix is a function that takes an n by n square matrix as its input and outputs a scalar. Before we learn how to take the determinant of a 2 by 2 and 3 by 3 matrix, let's go over some notation. Suppose A is our matrix with n rows and n columns. There are 3 ways we can express the determinant of A. One way is by writing det A. The second way is to use straight lines around our matrix, or we can just simply add 2 straight lines around the name of the matrix itself. Now let's take the determinant of a 2 by 2 matrix. There is a very simple formula that can be used to find the determinant of a 2 by 2 matrix. We take the product of the entries A and D and subtract the product of the entries B and C. For example, to solve for the determinant of this matrix using the formula, we have determinant of A equals -3 times 5 minus 2 times 1. And we get that the determinant of A is -17. Now we will go over 2 methods we can use to find the determinant of a 3 by 3 matrix. The first method we will go over is called the rule of Saris, which can only be used for 3 by 3 matrices. Consider the following 3 by 3 matrix. Take the first 2 columns and rewrite them to the right of the matrix. Now we look at the 3 full diagonals from the top left to the bottom right. And for each of these diagonals, multiply the entries, starting with the rightmost diagonal. We get 5 times 3 times 1 is 15. From the middle diagonal, we get -28. And from the leftmost diagonal, we get 32. Now we're going to look at the 3 full diagonals going from the bottom left to the top right. And for each of these diagonals, we will also multiply their entries. To calculate the determinant of A, we add the results from the downwards diagonals and subtract the results from the upwards diagonals, and we get 313. The second method we will be looking at can be used to find the determinant of any square matrix. The method of cofactor expansion requires that we choose a pivot column or row to begin. We can choose any of A's rows or columns to be our pivot. For simplicity, we will choose the first row. Now we can start to calculate. We will go through this pivot row 1 entry at a time. The determinant of A will be equal to the first entry in our pivot row, times the determinant of the matrix that's left over when we cross out the row and the column the 2 is in, minus the second entry in the pivot row, times the determinant of the matrix that is left over after crossing out the row and the column the -1 is in, plus the third entry in the pivot row times the determinant of the matrix that is left over after crossing out the row and column the 5 is in. Now that we've gone through all of the entries in our pivot row, we can calculate the determinant. Now that we know the formula to calculate the determinant of a 2 by 2 matrix from earlier in the video, we can calculate this easily, and we get 313. As we mentioned before, the pivot row or column you choose doesn't matter. However, depending on which one you do choose, you must follow a sign pattern in the equation. Notice that when we choose the first row, we started with addition, then subtracted the middle term, then added the last term. This was not by coincidence. When choosing a pivot row or column, we follow a sign pattern. To help us remember when to add or subtract, in our determinant formula, we can follow a sign matrix, that is the corresponding size of our original matrix. Since we picked the first row of A to be our pivot row, we will use the sign pattern from the first row of the sign pattern to follow. And that's how we knew to add, subtract, and then add when calculating the determinant of A.